So let's record.
Recording is running.
Okay, very nice, thank you.
Okay, let's start. We have about 100 plus participants. Welcome to our event, co-hosted and co-organized by WCA, Wireless Communication Alliance and Voler Systems. Please, if you can, please switch off your audio and video, please. We don't want to have any distractions here. Andrew, please switch it off. Thank you so much. Let's start. Okay, 5G hyped, overhyped, learn what it can really do. My name is Peter Walter. I am the president of the Wireless Communication Alliance. If you need any information about the Wireless Communication Alliance or about this event, or if you want to volunteer or have other ideas for other events, please let me know. You see my email there, peter.walter@wca.org, or go to wca.org and see the contact line. We were founded in 1994. The Wireless Communication Alliance is a non-profit business league. What we are doing from 100 feet above, we bring the wireless industry into Silicon Valley and with Zoom also all over the world. That is what we are doing in supporting students, universities, but also connecting companies and also consulting to each other to build one big community at the moment worldwide. Right. Here's our board. You see on the left side, Peter Walter, me, president. We have Jeremy Toll as vice president, Tom Hunt, treasurer, Tom Mitchell, secretary, Jeff Yen is director. We have another Tom Rao is another director. Our best heart as admin, I think 20 years in business here already, Christine Couture, and our marketing communication person, Arman Musavi, who is a student, is doing jobs with doing all the videos. So all of us, what you see, are voluntary. We are not volunteers. We are not getting paid. We're doing this with our heart. Sometimes it's much work. Sometimes it's just fun. We have to thank our sponsors, Aspir, CIG, Google, Voler System, and others like ETI, Energis, Mobile Export, and Sensitel. Without them, it would not be possible. Like we said, we are a non-profit organization. We don't have any income. We don't ask for money for these conferences. We just do it on our own. Please mute if you can. Please mute if you can. Okay. Thank you very much. Yeah. So a little bit of housekeeping. Use the Zoom comment section for question, or just open your microphone and ask the question. Presentation recordings will be available within 48 hours on our website. You will find it very easily. Last but not least, greetings to the world. We know we have people from Europe here. We have people from Middle East. We have people from Asia, China, very early birds because very early there, Singapore, and also Japan. Thank you so much to make this work and be part of our family. A little bit about upcoming events. The next event will be in August, end of August, real-time asset tracking. Where's Waldo? Then we have in September an Oktoberfest. I don't know how we can do this with the current situation about IoT, gizmos, and gadgets. Then we have our flagship event in November 2020. What's hot was not. Hopefully we can have an on-site event at the Silicon Valley Bank. We are working on this. And then beginning of January or mid of January in 2021, our annual Spectrum event, what's happening over there. With this, I thank you everybody again, and let's start now. I introduce our panel what we have. We have Walt McClay from Voler System. We have Paul Bradley from ARM. Actually, Walt joined us from Europe. We have Shine Khan from Orion X and Andy Du from Embedded Works. With this, Walt, short introduction to Walt. Walt is the president of Voler Systems, a leading design company focused on IoT and wearable devices. Walt is thought leader in sensors, wireless communications, and medical devices. Walt, with this having said, I stop sharing my screen. I wish you all the best. The show is yours. Thank you so much, and have a good show.
Thank you. Okay, so well, to start with, let me introduce our panel. Paul Bradley is here. Actually, he's joining us from Europe. He is the Strategic Marketing Manager, EMEA, for the IoT Platform Group at ARM. And probably a lot of people didn't know that ARM does more than provide IP for processors, but it does. This group is focused on building a technology platform of device and connectivity management to enable enterprise partners to secure, connect, and manage IoT devices. Andy Doe is the founder and president of Embedded Works, a wireless solutions integrator since 2004. He has over 20 years of experience in GPS, Wi-Fi, and cellular communications, and has launched several IoT brands focused on GPS telematics and wireless sensors. Shaheen Khan is the founding partner at consulting firm OrionX.net. OrionX works on technology, marketing, and policy issues that drive digital transformation. And that includes IoT, 5G, AI, blockchain, and quantum computing, an interesting list. And what I'm going to do now is give you a short introduction to 5G so that those who don't have some of the basics will cover the basics, and then some of the questions will make more sense. If I can just get started. Okay, so I'm going to cover what's promised for 5G, and then the technology. There's 3 different frequency bands, there's 3 different use cases, and a little bit about what this means for the future. So the promise, and you've probably heard much of this, is you're going to have this huge bandwidth, tremendous speed, extremely reliable, low latency. You've got always on capability. These are all very nice, but unless you actually see the numbers and the trade-offs, sometimes what's promised is not quite what's real. So let's start by comparing 4G and 5G. With 4G, you can get up to 150 megabits per second in some cases. With 5G, they claim you can get up to 10 gigabits per second. Haven't quite seen that yet. Latency of 4G around 50 milliseconds, and 5G, in some cases, 1 millisecond. The bandwidth or the spectrum for 4G is up to 6 gigahertz. And with 5G, it's up to 86 gigahertz. It opens up a whole new territory of very high frequencies. 5G promises a 10-year battery life. Any electrical engineer can see that you're not going to get all of this at once. We'll talk about that a bit. And the data volume, you can have 1,000 times more network connections. And then even in one cell tower, you can have 100 times more connections because it's directional. And you do get a lot more. So this is real. You've got huge capacity, fast data, so a lot more devices and faster data at the same time. Because there's new bandwidth, it's less cluttered, and 5G is more secure. Now, we'll talk about how this isn't all happening all at once. You don't get everything at once. It depends upon the frequency band in use. There's the high frequency bands have only limited availability. There are 3 different use cases we'll talk about, and some capabilities are not coming for quite a while. So to start with, the 3 bands for the spectrum. Below 1 gigahertz, that's been around in 4G, and the 1 to 6 gigahertz, that's been around in 4G, so we already have those. And these are being shared between 4G and 5G. So below 1 gigahertz has excellent distance, very good coverage even in rural areas. Peak speeds up to 100 megabits per second. So if you're in that band on 5G, it's only 100 megabits per second. It's being used right now by LTE. This bandwidth is very nearly depleted, though as the switch happens, it'll be switched from 4G to 5G, but the reason they opened up more bandwidth is because it's pretty heavily used. Then the mid-band 1 to 6 gigahertz, peak speeds can be up to 400 megabits per second. It's faster and has lower latency than the lower band. It doesn't penetrate buildings as well as the low band. It doesn't go quite as far, but you probably don't notice the difference. In fact, most of the time, if you're on a phone, you probably don't know if you're in the 1 gigahertz or below, or if you're in the 1 to 6 gigahertz. The performance is similar in those bands. Now with 5G, the new band, the 6 to 86 gigahertz, it's primarily in the US in the 28 to 39 gigahertz bands. This is substantially higher than what we've had before, and it's quite different. This band is referred to as the millimeter wave band. And the claim is up to 10 gigabits per second. There's a major weakness with this big band, with the high frequency band, and that is the coverage distance is very short, and the signals are blocked by walls, by windows. They don't get into cars, trees block them, rain or snow. So this is a very significant issue, as we'll see. Now, if we take a look at the trade-offs, at the bottom, the low band has very long distance. It'll travel 20 miles. Where if you look at the bandwidth, it's 50 megahertz. And bandwidth relates to the data rate. And latency is pretty slow. And as you go up to the high band, you get much better performance, up to what's actually 2 gigahertz. I haven't seen 10 as far as the bandwidth. And the latency, in some cases, as low as 1 millisecond. But the trade-off is the distance is far less than 1 mile. So it makes a big difference what band you're in. Now let's talk about the use cases. There are 3 entirely different use cases for 5G. The one at the top is Enhanced Mobile Broadband, EMBB. This is basically your standard cell phone service. And then at the lower right is URLLC, Ultra Reliable Low Latency Communications. This is for traffic safety, remote control, industrial, or remote surgery, industrial control. And then in the lower left, the MMTC, the Massive Machine Type Communication. This is basically IoT. This is smart buildings, tracking, wearable devices, and so on. Now, if we talk about the first one, EMBB, this is the cell phones, tablets, and so on. This is where you get the data rate up to 2 gigabits per second. So it's 20 times 4G. You can have very high capacity, so 1 million devices per square kilometer. This means theoretically 1 million cell phones within one cell tower. I don't know if 1 million would work. I don't know if it's been tested yet, but you can have a lot more. So drop calls will be a lot less. Now it depends upon your band as well. So below 1 gigahertz, you only get the 100 megabits per second going down and 50 megabits per second going up. So very similar to 4G. In the 1 to 6 gigahertz range, you get up to 4 megabits. And this is available in urban and suburban areas, but as I mentioned, a little bit difficult penetrating some buildings. And at 400 megabits, it's faster than 4G. And then if you're in the millimeter wave band, the 6 to 86 gigahertz, that's where you get the 2 gigabits per second. It's only available in dense urban areas. The range is so short that it's not available in suburban areas. So this is one limitation. I don't see that you're going to be seeing enough cell towers in an urban area, or a suburban area rather, that you'll be able to get the millimeter wave band. speed. So the ultra reliable, low latency. We have discrete automation, process control, electricity distribution, intelligent transportation. These are some very different use cases for cellular. These didn't exist in 4G. And when we look at discrete automation, it's 100 meters by 100 meters. So it's designed for one factory floor. Process automation, similar small area. But what's interesting is the latency. Latency down to 1 millisecond. So this is where you've got process control happening through the cellular network. Electricity distribution up to 200 kilometers, but it's just along the power line. And then with intelligent transportation, I think this was primarily aimed at cars. You're looking at 2 kilometers along a road. So this would allow allow cars to communicate between themselves. Now, these are going to be private networks that you won't be able to connect to with your cell phone. And then the third one, MMTC, the IoT use case. This is very different. It's very low power and wide area. This is where you can get up to a 10-year battery life. Now, as long as you don't send a lot of data. It's intended to be very good for 160 bits per second, not megabits, just bits per second, and up to 10 kilobits per second. You can have 1 million devices per square kilometer. Latency might be in seconds, 10 seconds. And for IoT, that's not a problem. Low-cost hardware is important. So it's a very different use case. The current state of MMTC is that 5G doesn't provide all that's promised. The new standards for MMTC are still being worked on for 5G. And 5G is optimized for high speed and not for tiny packages running at low speed. So it's inefficient. If you want to send 10 bytes of data, it takes 100 bytes of signaling to do it. The coding schemes are inefficient. And of course, the 10-year battery life doesn't happen if you're sending data all the time. It's infrequent messages. So let's just take a look for a moment about existing IoT services. You've got NB-IoT and LTE-M, which are part of 4G. They've been available for years, but they haven't been available widely installed, which they finally are. NB-IoT and LTE-M will coexist with 5G, so they should be around for many years. And they should remain compatible. That's what's been stated. They also have some issues about being optimized for small packets, but the coverage in the US is very good now. There are other non-cellular services like Zigbee, which is short distance, LoRa, which is long distance, Ingenue, Sigfox, Weightless, these are long distance. They use unlicensed spectrum, so the airtime is very low cost. They're not available in very many places though. So the future of IoT, for now, there's little change with 5G. But we do have good coverage for NB-IoT and LTE-M in the US. In some countries, we don't. So you have to pay attention. Mexico, it's offered only by AT&T. And in some countries like India, and South Asia, and parts of South America, there's neither one. So will today's devices remain compatible in the future? The plans are that they will, but standards are still being worked on. Just to give you an idea, this is the coverage map just for T-Mobile early this year for NB-IoT and LTE-M, and it's only getting better. So this is getting pretty close to coverage map for cellular. By contrast, for LoRa, this is the coverage map. If you sold a device using LoRa, most people wouldn't be able to use it, wouldn't get the coverage. So to summarize with 5G, you've got the millimeter wave signals that are they offer cool capabilities, but they're blocked by walls, windows, trees, cars, people, rain, snow. They don't transmit very far. With CNET, they did some testing. They reported that beyond 100 to 300 feet, it didn't work very well. That is from the tower, the base station. The phones themselves use more power on the millimeter wave band. So when the temperature may be just in the 80 degrees Fahrenheit, it may switch over to 4G because it gets too hot. The base stations use more power, so they're not as green. There are even concerns about health effects and interference with weather satellites with the millimeter wave frequencies. So with that introduction, I'd like to get started and ask some questions of our panel. First, Paul, I'd like to ask you a question. We hear about the new radio, the new techniques, new technology in 5G, but what's the prospect for massive machine type segment, including NB-IoT, LTE, M, and so on in the 5G system? Are you able to, we're not hearing you if you're speaking.
So while we're waiting to hear from him, we do have a couple of questions from the audience. So I don't know if the audience would like to hold off their questions and hear from the panelists to see in case their questions are answered, or if we should have you look at.
I think I'd like to hold off a bit.
Okay.
Do some key
Yes.
questions, but
Absolutely.
I
So
don't know if we have Paul here still. Is he still connected?
He was, I seen him muted earlier, but I don't see him anymore. So
might have dropped off.
Yeah.
So I will move on. Andy, I've got a, let's see. No, sorry, Shaheen, I've got a question for you.
All right.
Given all these technologies, what does 5G promise that makes it such a big deal? When we went from 3G to 4G, it seems like there wasn't as much hype, but there's a lot of hype now. So what's the big deal?
Well, I think there's a lot going on that justifies, first of all, it is the next generation. It has become a geopolitical hot potato in some ways. It does promise everything, as you mentioned, from bandwidth to latency to the geolocation precision down to less than a meter, to power, to coverage, all of the above. There's also a back-end benefit that the robustness of the back-end and the provisioning can lower the cost for telecommunications. And it is also the first time in historical technology where a next generation major technology is not being driven by companies out of the US or Europe. And that also makes it very interesting. And our research kind of suggests that 5G is very critical long-term, but at the moment it's the biggest benefit it will have is to reduce the cost of existing communication and make it possible for some of the use cases that we're not able to be cost justified to become cost justified.
Cool.
Paul has joined us.
I'm glad you're back.
Yeah.
I've got a question for you.
The LTE network let me down.
Yeah.
It was actually fiber. Even fiber can let you down. It's
yes. So in fact, that points out that there's this claim of 99.999% reliability, which I didn't talk about. In wireless, that's not likely to happen. So we hear about new radio, the new technology in 5G. What's the prospect for the massive machine type segment? This includes NB-IoT and LTE-M in 5G.
Yeah, well, that's a great question. So, from my own perspective, people get very hung up about 5G new radio. And for me, it's not about 5G new radio, it's about the 5G system. That's what changes everything. I think that 5G should be seen more as a platform for digital transformation. And ultimately, product management, those who are trying to deploy the massive machine type services, they're looking for to understand or to provide service to end consumers. somehow. And those end consumers could be working for enterprises, or they could be, you know, part of other industry verticals. And ultimately, they're after insights. So people, you know, use the expression "data is the new oil." For me, it's not at all data. It's the insights that are gleaned from the data. And you could have a product manager deploying a certain product in a certain market who needs to understand what's going on, where the product is, and when it's used, how it's used, and who they can ultimately gain insights from consumer behavior, which they could never have access to before, thanks to this machine type technology, which can be embedded in many different products that we never imagined before. Now, ARM is on a mission to get to 1 trillion devices that are connected over IoT networks over any types of networks, if you like, by 2035. And we reckon that around 15 to 20%, if today's trend holds, would be cellular. And looking at the latest information coming out from GSMA Intelligence, they're currently talking that the 1.7 billion devices that were connected over cellular IoT in 2019 will double by 2025 to 3.5 billion, despite somewhere between 2, 3, 5% impact from COVID-19. So that's ultimately something which everybody's to be expected. COVID-19 has both accelerated some digital transformation initiatives, and it's also slowed down others. So that's extremely important to keep in mind. So the overall impact is according to them and their enterprise members, somewhere around between 2 and 5% impact. But then, you know, again, I think one of the advantages that cellular IoT will always have over the other technologies is indeed the zero-touch setup and the frictionless setup. You can just install a device anywhere, you plug it in, and it will simply just work. And so NB-IoT today, LTE Cat-M today, and then later this new radio light technology, which will be specified as part of 3GPP release 17, that will also continue to help the deployment with different flavors of connectivity. So already we have a kind of an a la carte menu of different types of connectivity, different trade-offs between latency, between distance, between bandwidth, etc. And we're going to introduce another flavor, which will maybe be the killer one, who knows, but like let's see how that goes in release 17. But indeed, it's much simpler to deploy than Wi-Fi and Bluetooth. And in terms of our own experience at ARM, we've already seen that you know, that there's brand new use cases that are coming. So we've seen recently, we've worked with some partners. We've worked with Vodafone over in Europe. We've worked with Murata and Altair to produce an enterprise use case, which is pretty impressive, which is a smart label. And this was done for a big life sciences company called Bayer, and it was to protect product integrity as products were being manufactured and then shipped out into the field, and literally the field, because it was agricultural products in this particular instance. What we did was we built a cellular connected on the NB-IoT network smart label. ARM provided the security part where we integrated an integrated SIM, which is a SIM that is included in the system on chip. And it's basically, we managed to securely connect and track labels to be able to ensure whether products were either dropped, where they were at any point in time, when the product was opened, when the product temperature was too high, or when the humidity was beyond the product threshold, to ensure that the product arrived in the state it was intended. So that's just kind of one of many use cases that we see for NB-IoT networks as they start to emerge, and connectivity becomes possible in any type of form factor. And it's really, really incredible.
Very good, thank you. Andy, should 5G coexist with 4G, or should it replace it?
I think it has to coexist. I mean, today you have a lot of the IoT M2M type of devices that, quite honestly, don't need the extra speed. And we've heard of that 2G is still around in a lot of places. And, if you have a temperature sensor or an alarm system, it doesn't need to surf the internet. Of course, it just needs to kind of ping or phone home. So, given that the 4G deployment in the US and worldwide has kind of been, already been blanketed, unless there's a cost savings of some sort, there's no need to kind of rip out that network. And a lot of folks are, choosing the NB-IoT and the CAD-M as a subset of the 4G and building to future-proof their sensor network or their industrial IoT of sorts for years to come. So I think those two technologies have to exist. The 5G, because of the speed and because of the low latency, I think that's where you're going to gain, this greater usability in the VR and the AR, realm of things. And if you can imagine, a factory in China and a supervisor here being able to, virtually show the worker, how to do it with some sort of mechanical VR robot of sorts. This is where, something like that can be possible. There was talk earlier about, having the higher frequencies where it didn't penetrate buildings very well. So when, as a consumer, as we start using VR and AR technology, there's going to have to be complementary technologies to handle indoor. So Wi-Fi 6E would be a good example because it offers some sort of low latency. And if you are a technician or electrician even, and looking to do some factory repairs and you're inside, you might do a handoff from Wi-Fi 6E to 5G as you go outside to do that. But I don't see 4G going away. In fact, it might kind of accelerate because as cost goes down for 4G, there are going to be more and more things that didn't connect before. So.
There's a question, will 5G chips impact smartphone BOM cost or power budget?
Sounds like, Andy, do you have a comment on that one?
Yeah, I mean, will it impact smartphone BOM costs or power budget? Yes. I mean, right now it's a premium as a case in point to see what a 5G phone costs these days from a carrier. It ain't cheap. So certainly today 5G is for those who want to be bleeding edge. And a lot of the module manufacturers in which we work with as a company at Embedded Works, we realize that they're early adopters who want to have 5G routers or buying these modules, but they're in the they're definitely in the hundreds of dollars for a module, as opposed to what folks are used to in the sub $50 or $40 for a chip. So right now we have to kind of wait for economies of scale, but certainly the BOM cost today is meant for more high throughput and more high ASP devices.
Additional question for the panel. There is still struggling. There is still struggling in the 5G deploying, and hard to realize the benefit for 5G yet. But would be appeared. I'm trying to read this. But when would we be appeared, and which country would lead this industry?
I can comment on that.
Thank you, Shaheen.
Sure. So we look at it from 3 dimensions. One is just the technology and the standards. There's obviously the ones that have been mentioned. In that particular area, China seems to be leading. Huawei seems to be leading. On the handset front, Qualcomm has always been strong and continues to be one of the global leaders, if not the leader. Obviously, the ARM folks, as Paul has been mentioned, are putting a lot of the underlying technologies. There's also Nokia and Ericsson out in Europe that are doing the switches. There's also a software approach with Open RAN and the serverization of the switch. That is a technology that's going on that may very well end up being, right now it's not really at scale. It's not kind of ready for telco implementation, but it may just surprise you. You may just be able to combine that with elastic cloud from people like Amazon, and boom, suddenly you have a solution that you never expected would actually work. So that part is a mix. The second part is the deployment. Now, the deployment is a question of infrastructure and investment and government policy and social acceptance of all of these things. And we see between China and Europe both doing quite well in implementation of that. There's a lot more resistance in the US, and there's a lot more just kind of catching up with things. And then finally, and this is the most important thing, is what are the actual applications, right? If you want to do 5G and play, Candy Crush on it, that's one thing. If you're actually doing telesurgery or some serious or driverless car or fleet management of autonomous vehicles within an urban area, those kinds of applications kind of do seem to need 5G in a legitimate way. You really cannot do that with Wi-Fi, BLE, LTE, and combine the three and be smart about it. So to me, ultimately, the economic impact of that will be the applications. And for that, right now, it seems like, the North America, US might just be ahead of things, entirely because you're looking at not just IoT, but also AI, also transaction processing on top of these systems, low-cost microtransactions at scale. Now that kind of takes you into blockchain and cryptocurrencies, and suddenly you've got a buzzword soup that you need to put your arms around. And that will be ultimately where the value is. So we think it's going to be all over the map. And it's best to just kind of look at, what this forum is trying to do. What is hype? What is real? When is it going to actually deliver value? And that's going to be the ultimate metric.
I have a comment from Alan Wiesberger. Alan, if you could unmute yourself and ask your question.
Okay, I'm Alan Weisberger. For the last 11 years, I run the IEEE technology blog, which is IEEE's most popular website. And I've done very serious investigation of both 3GPP, Release 16, and the I2R IMT 2020 standards. And rather than ask the detailed question I put in the chat box, which everyone can read, what do the panelists think about the fact that all these claims about 5G being standards compliant are totally false, because there is no standard of any kind? And IMT 2020 hopefully will be completed late November. 3GPP Release 16 really is not complete. Ultra low latency for the RAN is only 53% complete. No performance testing yet, no schedule for same. So what do you think about all that? And that lack of interoperability and multiple implementations of 5G core, for example, could that not fracture the 5G market and cause it to dissolve?
Who would like to take that?
It's a good question. I don't think I could, possibly even, make a proper answer for it. But I know that there's a lot of. I would agree with all of your comments and with the fragmented kind of nature of 5G standardization, etc. And the fact that specs are never fully complete, or they're never complete enough. However, I believe that a lot of the effort or the gray area in specs comes at carrier certification time. So it's when carriers bring together equipment from several vendors that some of the behavioral issues are ironed out, and they somehow get aligned at product line stage. I know it's not maybe an acceptable answer, but typically there's enough gray area in standards such that vendors can use in their favor sometimes. So as well.
So I'll comment on this. It is without question what you're saying is true. It's like nobody can argue with that. There is the scope of this thing is so wide, and the level of activity is so varied, and so many different angles to it, that really anybody can claim anything and effectively get away with it, because for everybody else to go and study and see what part of it is true or not is going to be a problem. Part of, I think, the solution is indeed forums like the Wireless Communications Alliance that can bring some coherence to it and be a trusted source that can clear things up. At the same time, there is something about this that is very real. So while the hype is hype and we can safely ignore it, the reality of it is also real. And that part we kind of don't want to ignore to the extent that it can be used for the right applications. I also agree that the set of applications for which 5G is absolutely necessary right now, that you really cannot do it in any other way, is not that large right now. I mean, even if you kind of, Walt and I were talking about it in a different forum, if you look at like a stadium where there is a bunch of density and you've got thousands, hundreds of thousands, maybe, at least 100,000 in some places, devices that you could arguably, and plus you got all the IoT devices in there, that seems like a perfect place for 5G, except that it's kind of a solved problem. They've already done it. Now they've done it with brute force, they've done it with other technologies, but it's there. Telesurgery, it comes up, okay, great, but exactly when do we think we're going to have someone provide surgery from a different location? That seems like a little far-fetched until it actually happens. So I think at the end, I think we all agree that there is something here that is real, and we need to understand what part of it is.
Yeah, if I can add, I mean, this reminds me of what the Wi-Fi industry had gone through in the early days when there was an 802.11 spec. It's a spec written by a committee, and in every single company had to interpret what that meant. So Lucent and so forth, all these companies came out with their own version of 802.11, and their equipment, 100% it would work. But if you end up using, another party's equipment, even though they read the same spec, it did not work very well. And that was when the Wi-Fi Alliance jumped in and said, okay, we're going to vet all the equipment, and we're going to try with all the access points, and we're going to see who's compatible and not. And by doing so, then you get that nice little logo that you are Wi-Fi, Alliance compatible. So I see, there could be an industry where, there's a vetting industry, right, to see who truly is adhering to the 5G standard. But right now, Shaheen said, this is very real. People are building early days, applications with this, and whether it follows the standard to the T, no. But this is how new technology gets built, right? There's a phased approach.
Just one more thing. Every 5G core standalone is different. They're all different. They're all done in conjunction with the wireless carrier and the network operator. There's no standard for 5G core, and it won't be for a long, long time.
Yeah.
So we have a question from Doug. Doug, you're unmuted if you'd like to ask your question.
Yeah, I like to sort of follow up with the previous question, not necessarily just totally from a technology perspective of the standard. Given the Huawei and all the political shenanigans surrounding it, could that be a case where a phone that would talk to a Huawei network but would not be able to talk to non-Huawei network? Would that be a possibility in the future? Meaning that you travel one area to another, you might not be able to use the same phone.
That is a possibility, but if you are any legitimate manufacturer, you go through certifications like PTCRB and so forth. So there is a committee that makes sure that you have you follow spec. So yes, it's possible, but I think manufacturers would be shooting themselves in the foot if they did make a product like that.
So we have a question from Jeff. What industry impact do you see from an open ecosystem approach like a telecom infra project?
At least from my perspective, I think that they can potentially accelerate things because, again, they're kind of sets of vendors who are coming together, and rather than writing documents and specifications, they're doing. And I think that, with all the nature of open source type projects, this does accelerate things, and it does bring people to a reference implementation rather than just text in Word documents.
Paul, Hassan has a question. He thinks ARM is leading the ISIM activities. What is the status of ISIM standardization?
Yeah, I had already answered that one in the chat. So in fact, indeed, the ISIM has already been somewhat standardized for the M2M type of remote SIM provisioning. And the consumer flavor is coming a little bit later on.
Sorry for the repeat question there. Thank you for clarifying.
So I've got a question. Paul, how does security evolve in 5G? How does it compare to what we've had before?
Wow, that's a really good question. That's actually my my favorite topic is security. So thank you, Walt. So the main risks up until now was on LTE networks and on other networks was really around eavesdropping, data manipulation, and fraud. So that's the reason why we had so many different security mechanisms that needed to be entrenched into the cellular networks. But with 5G, you have different types of risks. You have data breaches that can become much wider. So if you think of edge computing, which is one of the key elements of a 5G system, you could potentially today a lot of the cellular sites are remote and they're protected by nothing more than barbed wire and a padlock with a combination. And that's what a typical cellular site looks like. And going forward, we're going to be putting data center like equipment in there, and we're going to be processing data at the edge of the network. And so the security of those sites will need to shift completely. Then data manipulation can lead not just from eavesdropping and collecting information and interpreting information, but really to opening doors, driving cars. You know, it becomes, security becomes a much bigger ball game, if you like, in 5G. And then you also have the possibility to deny critical services. I think it was Shaheen who earlier on mentioned remote surgery. Imagine a denial of service there. This would be unimaginable. And so it becomes critical infrastructure. So we've been focused on several different things in that space to try to ensure that we protect the data as much as possible. One of the things we've been working on alongside ISIM is a means of protecting the data from the chip to the cloud. So this is an initiative called GSMA's IoT Safe. And what this does is this uses the SIM or a secure element inside the device to encrypt, to establish the TLS or DTLS handshake between the device and the cloud. So you're protecting the credentials in hardware rather than just kind of loading certificates directly into the device flash. And then we see that there's a real simplification step, which provides a single pane of glass by which enterprises can manage their connectivity credentials and decide which mobile operator or wireless carrier to put the devices onto to use for connectivity, and also to be able to manage the cloud credentials and the life cycle of those credentials in parallel. So that's one of the things that we think will be extremely useful. Then in terms of privacy, we have a new feature within the 5G network, which is to ensure that your principal identifier, known as the subscriber's permanent identity, or formerly known as the IMSI in the public network, is encrypted. So that is now exchanged with the network only in an encrypted form ever. And that means that we'll have a stronger level of consumer privacy. We also have three new types of authentication, or three types of authentication in 5G networks, which strengthens things. We have a primary authentication, which is used to authenticate for the connectivity to the cellular network. We then have a secondary authentication, which is used to authenticate to an external data network if we want. So like a network behind an APN. And then a third type of slice-specific authentication, which can be used by the enterprise if they go for a network slicing approach and they wish to be able to authenticate the device coming into the slice to ensure that it has access to the data or whatever the services are within that slice. So that's something which is extremely useful. And then there's one last thing which has happened for security in general, which is enhanced home network control. So before a roaming carrier could allow you, could authenticate you and allow you onto their network, or be the entity that, let's say, accepts you into their network by comparing the authentication result from the device with that of the network. And now that's going to be the home network that will do it. So it gives the home network more control to allow the roaming to go ahead or not. So it gives them more control, and it leads to less potential fraud when you're roaming. So there's a lot of massive things in there, and that's just a few of the various security enhancements that have gone on in 5G networks.
Thank you, Paul. That's very helpful. Brian, your question?
Oh, yeah, thank you. It's something I kind of take out for Paul, and essentially, you know, ARM, like I said, for what they're doing for ultra low power cores and everything, you know, kind of processor per watt, if you will, I think is incredible. I think they're really leading the charge on a global basis in many accounts, from tiny power IoT doohickeys to, you know, servers and higher power things and, you know, whatever, SCADA, PMUs, whatever you want to call it. But what I see, and actually the area I focus on is kind of the high level, you know, whether it's a system level, grid level, network level, that essentially the kind of the microwatts to terawatts connection that most people don't see. So what I'm wondering is, you know, you've done a good job of tracking it at kind of the device system level and enabled a lot of energy efficiency improvements. But you're also in a fantastic position to, you know, educate the people in the world of that linkage from the microwatts to the terawatts, and how on either end of those spectrum, they're actually highly dependent on each other, whether that's obvious or not. So that's kind of most of what I'm wondering about, Paul.
Yeah, so ARM has an approach called total compute, and it's again to ensure that the payload is most efficiently managed in the right place and in the right way using the right type of processor. So that's really something which is ongoing. And as you've probably heard, ARM has a range of processors that is also addressing the data center, called Neoverse. And so we're not just in the device endpoint anymore, we're now also in the cloud. So it's pretty interesting. You've probably seen the announcements about AWS's Graviton 2, which is based on ARM. And again, all of the initial results that are published on that and the efficiencies that brings are pretty promising, and we're really excited about what's going on there. So yes, there's a lot to be done. Yes, there's a lot to continue improving. ARM is continuing to be focused on size, power, and ultimately cost by doing it in an efficient way. And yeah, you know, and then hopefully ensuring that the power is saved and that you know, it becomes a more sustainable solution.
Well, you should mention.
Okay, but nothing on how you're linking all those things from kind of the small level to high level. And just by the way, for everyone, that wasn't a straw man. I'm not a paid endorser or anything like that. I just believe in anything that saves power and energy efficiency, and I give them credit for that. But it's that disconnect from the lowest level to the highest level and harmonizing that I think is the biggest gap in our industry and all that. So I with all due respect, Paul, I didn't quite. I mean, you're attacking the individual pieces of the black boxes, but still not. I still don't quite understand how you're trying to connect all of them so that people get that visibility from one end to the other. Would you mind elaborating on that, or maybe it's an offline thing? And I apologize.
I'll take it offline if you don't mind, because you know, again, I have a rough overview of what we're doing in the Total Compute Initiative, but yeah, I can get you more details about that.
We have a question.
Fair enough. Thank you very much.
Okay, no problem.
Can I interject? While we're praising ARM, it must be said that the fastest supercomputer in the world today is based on ARM as well.
Regarding Apple, again, Apple tends to wait to get it right. So what do you, the panelists, think they'll do versus the rumors?
Well, I think Apple, you know, with its clout and you know, brand loyalty, I mean, they have the ability to kind of be their own micro carrier, if you will. You know, they certainly have the ability to, you know, offer connectivity and of course having some arrangements with the carriers in terms of getting it right, what 5G they will use. I mean, they are a market leader, so I'm sure, you know. I can't answer for that, but I just say that, you know, Apple's always impressed me in terms of you know, bringing the latest technology, but also do it in such a way where you know, that they can make sure that, you know, it's not that the network and you know, is there, and they don't kind of overcommit to too many things. So it's a general answer, but you know, I think they do the due diligence.
Okay.
So to the attendees that are in the audience, if your question has not been answered, would you please raise your hand and allow us to unmute you so you can ask directly?
So in the meantime, let me ask Andy a question about how will 5G be used in the private and public sector? Now, we've got for the first time private networks, which we haven't had, but
Yeah.
there's other factors. So tell us about that.
Yeah, there's a movement, where I call the BYOT, bring your own tower, with this whole CBRS, citizen broadband radio service, I think in the 3.5 gig, frequency band. And for the first time, an entity can have their own 4G/5G kind of network. And I think because of the expense of building that type of network, I think the private sector will have a lot of use for it. Imagine you have a huge automation or factory where you don't have to wait for the cell phone company or the carrier to come and bring the tower. You now have the ability to get the cellular performance and the efficiencies that you want. And there are probably 40 or so manufacturers today that are making equipment ready for that market. And so that, of course, has kind of requirements for licensing in your local county or geography. But I see that the private kind of LTE will initially be the stronger growth segment, knowing that companies can now control their own tower-like network.
Thank you. We have a question by Todd Parker.
Yes, thank you. My question's a couple layers higher, and hearing all the different use cases, including the remote surgery, which I hope I never have to have. My question is this: is there enough smarts, intelligence being built into the network to have different QoS built into the application layer, so you can look at the application layer and understand how you want to transmit that? And secondly, on the RF front, will there be some sort of understanding of what application am I running, and thereby what RF signal I should be picking up for that application? Thank you.
So on the first part of the question with regards to the application layer, I think that a lot of applications will somehow need to be predetermined as to where the counterpart or the system or the service counterpart will run. And I know that there were some projects launched. I believe Ericsson were doing some work into that as to the different topologies as to where the edge compute application would literally run based upon the latency requirements of the specific application. If it's something which is requiring that 1 millisecond of latency further than the edge, won't work because obviously you're going to accumulate some round trip times the further you go into the network and back into the public cloud. Whereas if it's something which can cope with a much bigger latency, then again you can you need to. You can live with it. You can go further back into the network. You could maybe have it at an aggregation point, or you could have it further back into the public cloud.
Okay.
Thank you.
So I've got a question for Shaheen. Talk about precision positioning. This is something we haven't touched on yet. Compare what you can do with 5G and GPS.
Well, I think the combination of 1 million devices per square kilometer plus precision down to a meter of geolocation accuracy, and I think with additional triangulation, you could even make it shorter than that. That can really make a big difference for many applications and may itself enable some geospatial applications that we couldn't have before. Referencing a previous question, one place this could show up is in fact in defense-related and classified applications, where you do need that level of precision for asset location and management and logistics and things like that. So that, in fact, is a very promising part of this, because it seems like it is a lot easier to achieve in the presence of a few other requirements that it might have. On the other hand, like you said, if all of these devices are going to transmit gigabytes of data, then maybe you're not going to have that much density. But that may still be okay in terms of just precision of the allocation.
Okay, very interesting. It seems like we've got lots of interest, so I'm not going to end the questions yet. I'll continue on for a while yet. So Paul, I got a question for you. How will enterprises benefit from network slicing? How will they protect access to their slices? And would you start out by explaining to some of us what network slicing is?
Yeah, sure. So as we virtualize networks, so virtualization being the fact that we run standard or somewhat standard functions on standard hardware, and then that we can pretty much chain those functions together to form a network. So today, most of what's being deployed in LTE networks, or up until now, was physical boxes. So more or less one 3GPP element related to one box. And that box was a set of hardware that was chosen by a given vendor, and then software was integrated on top of that. So now with this shift to virtualization, what we're doing is we're literally taking the standard hardware, just like you would in a cloud compute center, and we're instantiating virtual network functions in using what we call a network orchestrator to build up all of the different parts of the RAN. And so virtualization is really a key building block of 5G networks. At least standalone 5G networks, I think, will require a hell of a lot of virtualization. And so what we can do then, once we have a virtualized network, is what we call slice it. And what slicing it involves is, I don't know about yourselves, but we have an IT department who make a kind of standard configuration for our laptops. And you might then have different variants. You might have one which is for sales folks, which might have links to salesforce.com. You might have other with engineers, which might have different types of software, etc. And you have different kind of images of the laptops. So if you imagine that kind of process, and then you could make different images for different types of networks. So you might have one image which would be configured in such a way for IoT networks, which would have extremely access to some functions which might be deployed at the edge, or they might be even further back. Who knows? It depends on the exact need. You might have other functions for the remote surgery use case, which might have ultra low latency characteristics, where some of the functions would be deployed, or a lot of the network functions would be deployed very close to the edge, etc. So you can really tailor the network connectivity according to an SLA agreed between the enterprise, who are commissioning a network slice, and the connectivity service provider. So it's really tailored connectivity to a given need. And so when you combine that network slicing with the edge compute, you're building this kind of chain of trust from the device endpoint through this edge point and then onto the public cloud. And it means that you can process the data where you need to and where is most optimal. So that would mean that maybe some of the enterprise data would be treated locally at the edge. You then could dispose of what you don't need and just take the valuable insights, what you really need, back into the public cloud for later storage. So, again, if we were to save every byte coming from every sensor and that's being generated by the IoT the way it's envisaged, we'd never have enough storage capacity to be able to store it. So again, one of the things which is being done is to process and store enterprise data within these 5G network slices. And in order to be able to secure those slices, what we're going to do is we're going to add in the possibility to do an additional authentication between the device and the network slice. And what that ultimately means for the enterprise is that the mobile network operator or the carrier, what they'll do is they will first authenticate the device for the connectivity use case and say, okay, this device is authorized to use my public spectrum because I own the public spectrum and I need to authenticate the user for that. And then as soon as you go on to connect to the slice, you have an optional secondary authentication, which would be the enterprise saying, right, I'm allowing this device into my slice to access my services or to be in a zone where my data is and is going to be securely segregated from the rest of the cellular network functions. So so it's basically it provides a hell of a lot of flexibility for enterprises who wish to have mobility use cases, because again, you have private networks, which is something again that's very different. But you know, again, for those use cases that require both mobility and a separate segment of network, the network slicing is a fantastic technology.
Thank you, Paul. Very helpful. Maloon has their hand up from YouTube Wave Inc. Maloon, can you ask a question?
Hi, yeah, my name is Milan, and the question I have is pertaining to more to satellite communication. So, what is the prospect for use of satellite and 5G frequencies interchangeably using dynamic spectrum sharing?
Who would like to take that one? I can comment on that. One problem you got, if you're talking about using a cellular network with satellites, you got a real problem with distance. The satellites are about 100 miles away, and your cellular communication won't go 100 miles. So they're pretty much separate.
Yeah.
What if someone has a low orbiting satellites with routers installed?
Even a low orbiting satellite is 100
Yeah,
miles.
like nowadays you have like gallium nitride power amplifiers, which can really, and with phased arrays, you can really build radios which can have really high ERP levels that can cover like low Earth orbit, at least with high fidelity.
Okay, if you're building something other than a cell phone, you could do that. Okay. I don't know about the sharing of the networks though. Can anybody comment on that?
Like the use of 5G spectrum in SATCOM and the use of SATCOM dedicated spectrum for 5G, and then using them at different time slots with dynamic spectrum sharing. Instead of some company like Verizon spending millions and millions of dollars buying spectrum, you just rent spectrum and use it whenever you want.
Interesting idea.
It looks like we may not be able to give you much comment on that issue. Sorry. You got 3 experts here, but not on that area. I've got a question for, let's see. Yeah, I got a question for Andy. Paul talked briefly about the effect of COVID. So talk to us about the importance of 5G with our current COVID-19 era.
Well, you know, when I was doing research yesterday about what kind of unique applications of 5G and COVID, one of the first things that came up on YouTube was a BBC report about how 8% of the folks they polled in the UK believe that 5G is one of the root causes of COVID. So there's conspiracy theories abound, but no, I mean, I think today 5G technology might be very relevant in the COVID era because as you look around, at least here in the county that I live in Santa Clara, Silicon Valley, you are required to check or people count in some ways, or check temperature, to make sure that they're not sick, and that is a person that has to physically do that. As I've gone to some of the home hardware stores, there's someone that sits there at the entrance and someone that sits there at the exit to make sure that you don't exceed the amount or the people per square footage of your facility. And with 5G technology, I could easily see a device that in real time can kind of alert immediately as a crowd that would maybe go in at some point, if they did not have someone who's sitting at the door to be able to monitor and kind of box out that this person is kind of reading a higher temperature or is displaying signs of they're sweating or something. So I think that technology with 5G could really enhance kind of that real time doctor at the door concept. As well, today, virtualization and remote, work from home, learn from home is key. I think you've heard reports from the carriers that they've seen an increase in traffic, obviously, from all of us working remotely. And, it's not a perfect system because in the course of this, this forum, we've had some drops and so forth. And, so if, for me, I think that it's exciting that whatever the real 5G would, might be, whichever one tends to stand up. In the past, there's really only been 2, maybe 3 ways to get broadband to your house. There's the cable company, there's the phone company, and sometimes, a fiber company. But, the thought that one day that you might be able to go to your local Best Buy and buy, a device that allows you to connect and pay for the service is exciting. And I think that would allow businesses to kind of do the same, to be able to innovate and build this kind of near real time. And with the 1 millisecond latency, that's going to open up a lot of virtualization. Again, AR, VR, it's something today that most people think it's more about goggles and games, but it is very real. Where companies, semiconductor companies, are using it for part of their assembly line and so forth. So at COVID era, I think 5G is going to maybe accelerate, that based on the need.
Okay. Well, I've got one more question, and then we'll wrap things up. For Shaheen, talk to me about cost. Andy said a little bit about the high cost of 5G, but what is the cost now, and what does this look like for future markets?
Yeah, cost, of course, as you guys would know intimately, is a very complicated topic because it also is directly related to volume, and volume is related to your business case, and business case is related to the applications. And in fact, most of the IoT projects that we see kind of could benefit from a better business case up front. And of course, at the end of the day is the street price of whatever it is that you're selling. For things like high-priced cell phones that can go for $1,000 or more, there's a lot more latitude to really think about. A couple of dollars here and there may not make a difference, but if you're trying to make for the sake of argument, if you're trying to make a 5G light bulb, then the BOMs for that better be no more than a couple of dollars, and they better be able to operate in a heat that's going to go up to like 120 degrees or whatever it is that even LED gets you, and it better be small, and it better be this. So all of those really restrict what you can do. And I think as a result, given that 5G is a premium service, the expectation is that it'll be more expensive than what you can get with LTE and BLE and others. And I think it's going to push some of the use cases down rather than accept them in. That is our expectation. But it seems, I don't have the latest info, but the last time we tried to drill down into it, it seemed like it was really difficult to get too much below something like $10 a unit for the BOM cost for that. I don't know if that corroborated with what you're seeing.
Okay, well, thank you. We've covered a lot of different areas on 5G, and there's still more areas, and we're only just focused primarily on IoT. But it's been great having these experts to help us out, and I appreciate all the questions from the audience. So thank you very much. This will wrap it up.
Thank you, Walt.
Thank you, Walt. And, just one last comment from my side. So, again, I mentioned the ISIM work that's ongoing, and if anybody is interested, we will be accepting candidates for pilots in the coming months. So feel free to reach out to me on LinkedIn, and I can introduce you to my US-based colleagues. So thank you.
Thank you. Yeah, very good. Any last words, Peter?
Okay, thank you very much, Walt and panel, Paul, Jane, and Andy. We learned a lot about 5G. I call it always the good, the bad, and the ugly. We will hear a lot of other 5G notes and news in the press and also newsletters here in Silicon Valley. You can have 5G and IoT events three per day if you don't need to work. I like the idea, Andy, from bring your own tower. Definitely we should follow up with this someone. Perhaps we can make an own event or a single event out of this. And like I said, the next event would be about real-time traffic, real-time asset traffic. So probably we can also bring GPS and 5G, was somebody mentioned also in this game. Does it make sense to have 5G and real asset traffic, real-time asset traffic also together? With this, if there are no other questions, thank you very much to the world and to our participants. Start from the East to China, Japan, Singapore, Europe, Middle East. Thank you, Paul, for joining us from Europe. It's hopefully not too late for you. Yeah, we'll see us again end of August. Let me know if you have some other question, peter.walter@wca.org, or go on our website and fill out the contact list. With this, thank you very much again. I close the meeting, and yeah, it was a wonderful event. Talk to you soon. And stay healthy, of course. Thank you very much.
It's our pleasure. We'll be sharing the video and the chat. Any additional questions that you might have, you'll have access to the panelists, the experts, as well as the websites and the video. We really appreciate your attendance and look forward to having you join us again in the future.
Thank you, Rio. Yeah, thank you, everybody.